Hello everyone, this is Dr. Doug, and in this video I'm going to give you a very brief introduction as to what the mole is and how we kind of use it. In following videos we'll actually do math with the moles and talk more about molar masses and formula weights and stuff like that, but I just want to give you an introduction onto what the word means because it seems to trip up a lot of students, or they'll just use it without really thinking about it. So to go back to the periodic table, right, here's just a tab, one of the tiles for nitrogen, right, a really common element. And just as a quick reminder, the capital N, right, that's just your atomic symbol. Up here, this 7, right, if you remember, that's the atomic number. So atomic number. And that gives you, right, the number of protons that element has. So, for example, nitrogen has 7 protons, and that identifies the element, right? So anything with 7 protons, regardless of neutrons and electrons, that's nitrogen. If it has 7 protons, it's nitrogen. And then lastly, we have this 14.007 down here at the bottom, and that is our atomic mass or our atomic weight. You'll hear both, atomic mass / weight. And if you look at this number, right, you have 14.007. That doesn't really have a unit, right? We talked about it being the total mass, and that roughly correlates to the number of protons and neutrons in that, and the most common isotopes. But 14.007, you'll see either the unit for that being AMUs, which is the atomic mass unit. The atomic mass unit, that's just 1/12. Here, let me do it in a different color here. That's 1/12 of the mass of a carbon-12 atom. So let me write this in blue. So AMUs, right, that is 1/12 of one carbon-12 atom. So carbon-12 atom. Which, as you can imagine, right, is a super small value. You're going to read about AMUs and hear about AMUs, but to be perfectly honest, no one really uses AMUs much. The units that I'm going to want to see you use for this 12.007, is going to be grams per mole. That's what people actually use. When someone looks at the periodic table, when a chemist looks at the periodic table, and we say that hydrogen weighs 1.0079, we think grams per mole. That's how many grams are in a mole of stuff. So you can write this as grams per mole like I did, that abbreviation, right? So we've got grams, right, for your mass. So grams, which is a unit of mass. And then we have this MOL, which is abbreviation for mole. She just dropped the last letter, that's it. So mole. You have this abbreviation for mole, which is a number, right? It's a large number, a very large number of atoms. And that's all a mole really is. The mole came from, right, this came from the number of atoms, and they were counted kind of by looking at electrons, more than atoms, but it's the number of atoms in 12 grams of carbon-12. Of carbon-12. And that number, that actual number, is what we call Avogadro's number. Avogadro's number. Apparently that number is 6 here, sorry, let me write this. 6.022 times 10 to the 23rd. That's how many atoms are in 12 grams of carbon-12. And we just call this number Avogadro's number. And it's just a number of things. It is a number of atoms, in this case carbon-12, but really it's a number of anything. And the idea here is that this mole is like any other word that means a number that you've experienced, right? So over here I have, words that mean pairs. Again, you guys have seen this before, right? We all know that that a pair is 2 things, right? You can have 2 people, you can have 2 shoes, you can have 2 bagels, right? You can have a pair of people, a pair of bagels, a pair of shoes. You can have a trio of things, right? That's 3, a quartet is 4. People know that a dozen means 12. A baker's dozen, right, would mean 13. A gross is a dozen, so that's 144. And a mole is just like all these other words. It's just these letters. It's just that these numbers are so small, and a mole is 6.022 times 10 to the 23rd things. And so just like you can have a dozen bagels, you can have a mole of bagels. It's just a ton of bagels. Just like you can have a pair of shoes, you can have a mole of shoes. Just like you can have a quartet of violins, you can have a quartet of moles. It's just a gigantic number. And we use this number, right, because atoms and molecules are so small that it makes no sense to talk about having like a pair of carbon atoms or a pair of sodium atoms or a dozen sulfur atoms. That's just such a small amount that we don't see that in our everyday life. No one is going to ever give you 144. No one's ever going to give you a gross of, for example, iron atoms. It's just way too small. So we talk about these things in these much larger numbers called moles. It's just a gigantic number. And so when we see things like 14.007 grams per mole, another way to put that in a sentence, another way to say that, and I'll write that up here, is that let's say if you have 6.022 times 10 to the 23rd nitrogen atoms, it will weigh 14.007 grams. So it will weigh 14.007 grams. All right, so if you had this huge amount of nitrogen atoms, that's how much it would weigh. And that's what the periodic table is telling you about all of the elements, right? That atomic mass, that atomic weight for every single element, that is how much 6.022 times 10 to the 23rd atoms of that particular element would weigh. And that's all the mole is really talking about. It's just a giant number, again, like a dozen, like a pair. It just is a word that means a whole bunch of stuff. So in following videos, what we're going to do is we're going to take that information, that atomic mass, that atomic weight, and talk about molar masses. And what do we do if we have things that have more than one element in them, and then do conversions between moles and grams to moles, and talk about how we actually weigh things and measure things. So I hope that you follow up those other videos. If you have questions or comments, you can post below. Thank you.